Okay, kids, I am just going to pick a question or two from each set. Again, the second part of your test looks just like the second part of your take-home quiz, that second page, front and back. Okay, so the questions are very similar. If anything, again, these are a little bit easier, I think, than the take-home quiz. So let's just randomly pick 43. So they want you to take these logs and condense them to a single log using the log properties. So since this is the 1/5 on the outside, you can just go ahead and distribute that if you want. There's a couple ways to do this. I go ahead and distribute it to each log. And then I'm going to combine the logs. You could combine the logs in the parentheses and then distribute the 1/5 as an exponent. I just think it's easier this way. So remember, the 1/5 means this is a root, so I'm going to go ahead and just write this step. If you were to skip this step on the test, I would understand. Remember, the root is on the bottom. Okay, so what I did was I brought these guys up. Oh, that's not 2/3. As exponents. And then I wrote them in root form. Now, finally, we're going to combine them. So this is addition, so we're going to combine them using multiplication. And again, you can kind of shorten that a little bit, because you can kind of see that they're going to be roots, and you don't have to write the exponents first. All right? Okay. So just remember all your rules. Adding comes together with multiplication, and your front numbers have to be in as exponents. Remember, exponents that are rational need to be written as roots in the final answer. All right, then you're going to have to expand some. So let's look for one that's looking kind of crazy. Let's, and again, nothing too crazy is going to happen on your test anyway. Let's look at 27. So we have the log of the square root of x squared plus 1 over x plus 3. So I have division. I am going to subtract and break it into two separate logs. You have to remember, this is a radical. So really, we could rewrite this first one. And again, if you skip this step because you just kind of already see it easily, you can do that. We're going to take this 1/2 out in front. So if you want to jump from, blue to blue, you can. And there's no exponent with the log x plus 3 to drop down. Okay, so remember, if you have a radical, you must write that as a rational exponent. And if you want to just immediately drop it down in front, you can. Okay? Anything in the denominator should show up as a minus, even if there's more than one thing in the denominator. And I know the big question is, well, they're multiplying down there, shouldn't that be plus? It is a plus downstairs, but then you have to subtract both of those when you bring them up, or however many there are. All right, next. Here you are expanding, and then you are substituting values in. So for all of these examples, you have the log of x, the log of y, the log of 2, and the log of 3. So these numbers have to be put in terms of those things. I don't know. Let's look at number 14. Okay, so we have the log of x, y cubed. So the first thing I'm going to do is I'm going to expand it. And I'm going to go ahead and drop that exponent down because I know it's going to be down there. You can do that in one step. Then you're going to look at the values that they gave you. The log of x equals 2. The log of y equals not 0.3, but 3. So this is 2 and this is 9. That totals 11, and that's it. You're done. Okay? All right. Moving on. For x and y. This is that systems that I think on the quiz, some of you figured it out, which is good. I think you probably got together and we didn't really do one of these examples in class, so it's one of those questions you're like, why are we doing it? So let's look at, let's do, none of these look pretty. Let's do number 3. So I'm going to expand this. So we see the multiplication, and we see they both have the power of 8. So it's going to be 8 log of x plus 8 log of y after you expand it. Okay, and if you have to do that step first, you can, okay? But we're expanding that. All right, and the other one, it is, remember, that radical is going to be written as the 1/3 power. So they both have the 1/3 power. So underneath here, I'm going to put 1/3 log of x minus 1/3 log of y equals 2/3. All right. So you have to think of the first number. We are just solving systems, so kind of ignore the log. Remember when you solve systems in algebra? You got to think of, we're going to eliminate. What's the first number that 8 and 1/3 go into? Well, the first one I think of is 8. Okay? So what would you have to multiply this 1/3 by to get 8? Well, it would be 24. Okay? So we're going to rewrite the system. The top equation stays the same because we didn't have to change it. The bottom equation is going to be 8 log of x minus 8 log of y equals 16. All right. When we add these together, you get 16 log of x. The y's cancel, and you get 48 on this side. So you get, when you divide, you get the log of x equals 3. And now you can write it exponentially. 10 to the 3rd equals x. Right? Now you could repeat that process if you wanted to. I'm just going to go ahead and grab the first equation and just solve for y. You can repeat the process and eliminate the y's, which means you'd have to multiply by a negative 24. And that might just be easier for you. Let's go ahead and do it. Let's just multiply by a negative 24. So we're starting again at 8 log x plus 8 log y equals 32. We're going to eliminate the x. So when I multiply, instead of by that positive 24, I'm going to multiply by a negative 24. Okay. Question is, when would you ever use this in life? I don't know. I'm going to be honest with you. It's a problem that only math teachers really like to figure out, I think. Okay, so now when I multiply here, I get a negative 8. So when I add these, the x's are going to cancel. And you get a positive 8 here. And you get a negative 16 here. Okay? So when I add them, these cancel. You get 16 log y equals 16. The 16's cancel because you're going to divide by 16. So 10 to the 1st equals y. So x is 1,000 and y is 10. Easy breezy, right? So we'll try not to make it too hard on the test. Moving on. Right, you're going to estimate. These are the large numbers. So let's pick pi. That looks kind of weird. So you're going to say k equals pi to the 650. And even, it doesn't matter what base you have, you're going to take the common log of both sides. This lets the 650 come down. When you have 650 as an exponent, no way, Jose, are you going to be able to evaluate that. But with our calculator now, I can pick it up and say 650 common log of pi equals 323.1. Remember, we want to leave these nice long decimals. Okay? So, in scientific notation, we're going to rewrite this in exponential form. So 10 to 323.147413 is what k equals. And I can split that exponent up between the decimal part of it times the whole number part of it. Because remember, when you multiply like bases, you add the exponent. So I can split them like that. And if I put this first 10 raised to the decimal portion in my calculator, I get 1.404, 3 decimals is enough, times 10 to the 323. So how many digits does this have? Well, we've got 323 here and 1 digit here. So you have 324 digits. Okay? So it's always going to be whatever this number is here, taken up to the next integer. All right, so pop it up. Moving on. Investments, we're going to double our money or whatever. Let's go ahead and do the last one here. Rate of investment. At what annual rate of return, compounded quarterly, would your investment grow from $8,000 to $50,000 in 25 years? So let's write the formula down. So that's your formula. So our account is growing to 50,000. Interest rate we don't know, that's what we're looking for, but quarterly means 4, so that n is 4. And 25 years is the t, so 4 times t here is going to be 100. That means how many times it's compounded over the life of the investment. So 50,000 divided by 8,000 gives me 6.25. We do not have an exponent that is a variable, so we do not have to do logs. Everything in the chapter is not just logs. So we want to get rid of the 100, so we're going to raise this side to the 100th power. That would cancel that 100 power on the right. And we really don't need the parentheses anymore. Then to get rid of the 1, we subtract by 1. And to get rid of the 4, we're going to multiply by 4. Okay, so the R is going to equal, and again, I'm just putting this all in my calculator, one big fell swoop in my calculator. Just double check it, make sure you've got it all written, and you've got your parentheses. 0.0, have it in my red marker. 0.07398, so let's say 7.4%. Okay, so don't automatically just jump to logs. You don't want to jump to logs all the time. I can't do the red and green. It's Christmassy colors. It's not going to do it. There you go. All right. Okay. If you look at some of the other ones, it says you're doubling your amount or whatever. Doubling, remember, if it's A divided by P, that's doubling or tripling. You're going to use that as a 2 or a 3. They don't have to give you your actual investment. All right. And also remember, when you see continuously, that's that PERT formula. Well, so A equals P, E to the RT. All right, half-life. So if they are looking for half-life, I want you to write both of these formulas down. If you're looking for your half-life, it is the natural log of 1/2 divided by your time. Okay? That's if you're looking for the half-life. All right, I completely missaid that. That's supposed to be K. Divided by your K, your rate of decay. All right? So K is rate of decay. So this is half-life equals natural log of 1/2 divided by the rate of decay. So the other half-life formula, the thing that we dealt with half-life, we kind of did an easy one like this. That one will always get you the value. But if you're looking for your half-life time, you kind of got to do this. Okay, this red one. So it depends on the question you're given. So we're going to do 2 of these. Let's look at the first one. We've got a radioactive substance that is effective in locating brain tumors, has a half-life of only 8 days. The hospital purchased 20 grams of the substance, but has to wait 5 days before it can be used. How much of the substance was left after 5 days? So they're asking about A or P. So we're going to use the blue formula. So in this case, we're going to come over here and say, all right, we're looking for how much is left. So that's your A. We started with 20 grams. The time period is 5, and the half-life of this stuff is 8. So I get, there's only about, it's 12.96, but we're going to say that's about 13 grams. Okay. So if you're looking for how much did you start with, how much do you have left, time, that kind of stuff, you can use this. But if you're looking specifically for what is the half-life time period, you need to use this one. All right. So let's see. Let's look at number 24 because it's asking for the half-life. 60 grams of magnesium decayed into 7.5 grams after 63 hours. What is the half-life? Well, you know what? I think we could probably use the blue formula for this one too, because we don't have the decay rate. I would use the red one for this guy right here, 23, or 93, sorry, because they're giving you a decay rate. If you don't have a decay rate, you can't use the red formula. You can use the red formula if you have a decay rate or if you have a half-life and you're looking for decay rate. Let's use the blue formula again for this guy here. You guys can try that 93 on your own. So we have 60 grams of magnesium decayed into 7.5 grams. So 7.5 grams is what we ended up with. You started with 60. Please don't use the 28, just in case you see a number. After 63 hours. So we're looking for the half-life here. We're looking for the H. So we have to go to work. It's in the exponent position, so that tells me eventually I'm going to be using logs. So we have to divide by 60 first. And again, I'm not going to use my calculator. I'm just going to leave it sit there like that. Now I'm going to take the natural log of both sides. You could also take the common log. Doesn't really matter. The only time you have to do natural log is if there's an E. So we're going to drop our exponent down. We're working to get H. So we're going to divide by the natural log of 1/2. So we get the natural log of 7.5 divided by 60, divided by the natural log of 1/2. Gives me 3. Well, that's nice. H is on the bottom, so we're going to cross multiply here. And I get H is 9. 9 hours. So every 9 hours, it decays to half. That looks about right. Okay. Okay, let's look at that. What's wrong with it? This is too much. It needs to go home. 63 divided by 3 is 21. It's 21 hours. I was figuring up the half-life going, that doesn't seem like it would get down to 7.5. It would be much lower than that. All right, so make sure you divide correctly. Here we go. Find the principal that will generate. So again, these are problems that have this formula or the PERT formula. It's an N. So either one will work depending on the situation. Let's just do annually. It's kind of boring. Let's do daily. Let's do 10,000. So we want to have 10,000 at the end of the time period. We're looking for what we invested. We're looking for the p-value. And our interest rate is 8%. So remember, that's a decimal 0.08. Over daily, we're going to use 365 times 10 years. So we are just looking for the p. So this is a simple divide problem. So if I do 1 plus 0.08 divided by 365, I'm just going to kind of put it together real quick. So it's not quite so crazy. It's still crazy. So I'm just going to divide by it like how it is. We're dividing by parentheses 1 plus 0.08 365. I am going to go ahead and multiply that. So we don't have two decimal or two exponents. So 10,000. Make sure you put that bottom in parentheses. I get, for P, $4,493.68. Okay? So, got to know that formula. You're not given that formula. You have to know that formula. And again, if it's compounded continuously, you would use the PERT formula. Okay? It's actually a little bit easier to maneuver with. All right, moving on. Name the transformations. So, guys, we've been doing this forever. So let's pick one. I don't know. Let's pick just number 80. So everything happened up top. I'm going to rewrite this so the x is first. The x has a negative with it, so you should rewrite it again, factoring out that negative. Remember, they've distributed through. So nothing's happening out here. So there's no vertical anything. Everything's happening up here. So we have a reflection over the y-axis, and we are moving to the right. Okay, if it's happening outside, it is vertical. If it's happening inside, I'm going to rewrite that again, it's horizontal. But if you have a negative with your x, please factor it out. And then, guys, that is it. Okay, so extra review Sunday, 5 o'clock. In my classroom, I think the musical is just ending. If the Commons is open, we'll go ahead and use the Commons, but if not, we'll be up in my classroom, and I'll just make sure the door is open. And that's it. We will see you on, hopefully, Sunday, if not on Monday. All the slides that we're going to use on Sunday are going to be on Polaris. So if you don't make it, no worries. Do the slides. All the solutions are there. It'd be better, though, if you need to ask questions if you're there on Sunday. All right. See you then.